In 2024, the Nobel Prize in Physics went to two men who never discovered a particle and never looked through a telescope. They built artificial intelligence. John Hopfield and Geoffrey Hinton won physics' highest honor, and I'll quote the committee, for foundational discoveries and inventions that enable machine learning with artificial neural networks. Not everyone in physics was happy about it. But here's what most people missed. That prize wasn't a mistake. It was a debt being repaid. Because AI was built out of physics in the first place. And right now, it is coming back to collect. In the last 2 years, an AI has found something inside plasma that our textbooks had wrong. Another one rebuilt the foundations of particle physics from scratch, without being taught any physics at all. And then researchers found a catch one that suggests AI might be the thing standing between us and the next great discovery. Stay for that last part. It changes everything. Welcome to Arthur's Physics. Let's start with the debt. In 1982, John Hopfield was working on something deeply unglamorous. Spin glasses. Materials where every atom behaves like a tiny magnet, and the whole system settles into whatever arrangement costs the least energy. And Hopfield noticed something. If you take that physics energy landscapes, atoms rolling downhill into a minimum, and write it out as a network, that network can remember. Show it a damaged image and it settles into the complete one. That's a Hopfield network. It is a physics equation wearing a computer's clothes. Geoffrey Hinton pushed it further and built the Boltzmann machine, named after the physicist who gave us statistical mechanics. It could look at raw data and find patterns nobody had labeled. The models writing your emails today are running on mathematics borrowed from the behavior of magnets. Artificial intelligence didn't come from computer science. It came from thermodynamics. Now watch what happens when you point it back. Nuclear fusion needs plasma heated past 100 million degrees, trapped in a magnetic cage. And plasma is violently unstable. Holding it means adjusting magnetic coils thousands of times a second, and every reactor's control system is hand-built by engineers. In 2022, DeepMind and EPFL trained an AI inside a simulation of a real reactor, the Variable Configuration Tokamak in Switzerland, and then handed it the actual magnets. It worked on the first attempt. No fine-tuning. It held the plasma in shapes that are genuinely difficult, including one called a snowflake. It even held 2 separate plasmas at once. It ran for 2 seconds, which sounds like nothing, until you find out that 2 seconds is as long as that reactor can run before it overheats. The AI wasn't the limit. The machine was. Then there's brute force. In 2023, DeepMind's genome predicted 2.2 million new crystal structures. 380,000 were stable enough to be worth making. That's roughly 45 times more stable materials than humanity had found in the entire history of science. And it isn't just on paper. Labs have already built 736 of them. But everything I've described so far is AI being a very fast assistant. Faster searching, faster control, faster prediction. Here is where it stops being an assistant. Dusty plasma is what you get when a plasma has tiny solid grains floating in it. It's in Saturn's rings and inside the machines that etch the chips in your phone. And we thought we understood the forces in it. A team at Emory University tracked those grains in 3 dimensions and fed the motion to a neural network, one they deliberately designed so they could read it, rather than a black box. The AI described the forces with more than 99% accuracy. And doing it, it broke 2 things physicists had assumed for decades. First, a grain's charge isn't simply proportional to its size, the way the textbooks assume. Second, and this is the strange one, the forces are non-reciprocal. A leading particle pulls the one trailing behind it, but the trailing particle pushes back. Not equal, not opposite. Nobody told the AI to look for that. It was sitting in the data the whole time. We just couldn't see it. And then, in March 2026, a team at NYU Abu Dhabi ran a test of the machine itself. They took particle data from the 1950s and 60s, the messy decades when physicists were drowning in new particles and had no idea how they fit together, and handed it to an AI. No theory, no hints. It found baryon number, it found isospin, it found charm. It rebuilt the 8-fold way, the classification scheme that helped win Murray Gell-Mann a Nobel Prize. And it found reggae trajectories, the link between a particle's mass and its spin. Decades of human insight pulled back out of the raw numbers. Which leaves an obvious question. What happens when we hand it the data we're stuck on today? And this is where it gets uncomfortable. To make these systems affordable, researchers use transfer learning. You train the AI on physics we already know, then adapt it to the new problem. In cosmology, that cuts the computing cost by more than a factor of 10. But in June 2026, Veena Krishnaraj and Adrian Bayer published something that should stop us. An AI trained on known physics can go blind to new physics, precisely when the new thing resembles the old. In their tests, the fingerprint of massive neutrinos looked like a parameter the model already knew. So the AI filed it away as familiar. It didn't report a discovery, it reported a slightly unusual version of what it already believed. They call it negative transfer. Sit with that. We are building instruments to find the unknown and training them on the known. An AI that has been taught everything we currently believe might be exactly the wrong tool for finding out where we are wrong. So is AI replacing physicists? Look at what actually worked. The Emory result mattered because the team built something they could open up and read. Their lead researcher put it plainly. Their method is not a black box, and human expertise is still essential for designing the model and for interpreting what comes out. That's the pattern in every one of these. A physicist who knew which question to ask, using AI to look where no human could look fast enough. The telescope never replaced the astronomer. It just meant they could finally see. So here's my question for you. If an AI hands us a new law of physics, one that works perfectly, predicts everything, and no human being can fully explain, is that science? Or is it just a very good oracle? Let me know in the comments. I don't think there's a settled answer yet. If you're watching this on Facebook, hit that follow button and share this video to spread the knowledge. And if you're on YouTube, hit subscribe and ring the bell so you never miss a journey into the unknown. Keep questioning everything. I'll see you in the next video, right here on Arthur's Physics.